Now let's say we are conducting an experiment, and in this experiment I want to toss two fair coins, and when I toss the coins, the sample space, when I toss two coins, the sample space is going to be either both the coins are going to be heads, or first coin is going to be head, second coin is going to be tail, or first coin is going to be head, or both of them are going to be tails. Got it? And now I'll create a new variable. Let us name it as x. Okay. Now what is the purpose of this variable is it will count the number of times head turns up. When I flip two coins, what is the number of times the head turns up? So that is counted by this variable. Then we can call such a variable as random variable. A random variable is nothing but a function which will take the events or the possibilities of the sample space, and then it will give us some number. Okay, so just see this, I'll explain you. Now if x represents the number of heads that can be possible when I toss two fair coins, then what are the possible values that x can take on? When you flip two coins, either both of them can be heads, or only one of them can be head, or none of them can be heads. Got it? Therefore the random variable x can take 2 or 1 or 0. And then if you talk about the probability with which x can take the value 2, x can take the value 1, or x can take the value 0, then it is called as probability distribution. Are you getting this? We are conducting an experiment as usual, like earlier, random experiment, and then we are not exactly interested on the exact output, like what is happening on the coins. We are not interested in that. Rather than that, we are interested in a function of the output. What is the function here? We are interested in the count of the number of heads, isn't it? Therefore such a variable x is called as random variable, and when we try to assign the probabilities for each possible value of x, then it is called as probability distribution of the random variable. I'll show you with few examples. See this one first. Now what is the probability that x can take the value 2? What is the probability that x can take the value 1? What is the probability that x can take the value 0? Now in order to find it out, we have to see what are the events that are favoring x equal to 2. If you have to get two heads, right? So first of all, what about the probabilities of each of the occurrence here? Since the two coins are fair coins, probability of getting a head is 1 by 4. This is 1 by 4, this is 1 by 4, and this is 1 by 4. This you already know, either by using that intersection, which is independent events, or by seeing that there are 4 events which are all equally likely possible, we are assigning 1 by 4. I think you know how I am assigning this, so I am not going to take that again. But then see this one. What is the probability that x is going to be 2? For this one, the favorable event is head. Therefore the probability is 1 by 4. Got it? What is the probability that x is going to take 1? So either this event or this event, both are favoring the x equal to 1. Therefore this is equal to probability of this one plus probability of these two events, which is going to be 1 by 4 plus 1 by 4, that equal to 1 by 2. What about this? It is nothing but probability of the event of getting two tails, which is 1 by 4. Got it? Let's see one more example. Let us assume that I am flipping a coin which is having I am flipping 3 coins, okay, 3 fair coins. Then what are the various outputs possible? All 3 can be heads, or head tail, or head tail head, or head tail tail, or tail head, or tail head tail, or tail head, or tail tail. Got it? Now all these events are equally likely because all the coins are fair. So for all these events we are going to give 1 by 8 as the probability. All are equally likely. Okay. Now assume that we are interested in finding out, let's say a new random variable x is defined, and x counts number of tails that come out. Okay, so let me call it y. You might get confused because I have already used x there. So x is the number of tails that may come out. Now when I am tossing 3 coins, how many tails can come up? Sometimes 0 can come up, or 1 or 2 or 3. Therefore there is a chance that y will take a value 0 with certain probability, 1 with certain probability, 2 with certain probability, and 3 with certain probability, and y is called as again a random variable. Got it? Why is it a random variable? Because it is not a normal variable, it can take any of these values randomly. Got it? And we can assign probabilities to each one of them. So see this, what is the probability with which capital Y can take a value 0? Right, such questions can be asked. Now if you want 0 number of tails, what is the event that is going to be favorable? Only this one, so which is nothing but 1 by 8. What is the probability that y is going to take a value 1? So what are the events in which you get only one tail? So 1, 2, 3, only 3 events, right? You can check it. Yeah, only 3. So it is going to be 3 by 8. What is the probability that it can take value 2? So value 2 is going to be 2 tails. So 1, this is 1 and this is 1. 2 by 8. What is the probability that we are going to get 3 tails? So 3 tails is going to be 1 by 8. Right? Did we miss out anything? Just see about 2 tails. 2 tails is going to be 1 here, and then 2. This one is also has to be counted, so that it is going to be 3. Okay, now check this. 3c1, 3c0, 3c1, 3c2, 3c1, 3c3. Okay, fine. So now again, this is the probability distribution for this random variable, right? Now if you observe this, there are certain interesting points about these random variables. Now if you see this, random variable is going to take each occurrence here and it is going to assign some value to this. For example, if you want to find out what is y of HHH, it is going to say it is 0. The reason is, in this HHH, even 3 heads are going to occur, the number of tails are going to be 0. Now if you take this HHT, then what is the y of HHT? It is going to be 1, right? So which means your random variable will actually is a function, it is actually a function, right, which will take sample space as input and give you some number. It can sometimes be an integer or it can sometimes be a range, but in this case it is going to take a sample space, yes, and in this case it is going to give us one of these 3 numbers, 0, 1, 2, 3. Got it? It is going to take sample space and it is going to give us one of the numbers, which means we can take any point from this and we are going to assign one number to that. You can even think of it here as well. So that is the first point. And the second point is, when you add up all the probabilities that are being assigned to the random variable, it will again be 1. So if you see this, you add these 3, 1 by 4 plus 1 by 2 plus 1 by 4, it is going to be 1. Similarly, you add these 4, right, it is going to be 1. Got it? So that is how we can think about random variables. Now let us say when I am going to roll 2 dice, so how many outputs will be possible? Totally s equal to 1 1 1 2 so on 6 6, which means 36 outputs will be possible and the probability of each output will be 1 by 6, right? And then we can define a new random variable z. Okay, 1 by 36. We can define a new random variable z in such a way that z is the sum of whatever comes on two dice. So if z represents the sum of values on 2 dice, right, then what is z? Z is a random variable again. Then what are the possible values for Z? So Z can take either, Z can give you either values 2 or 3 or 4, so on 12. So why is this so? Because when I roll 2 dice, when I add the whatever comes up on these 2 dice, it can either be 2 or 3 or 4 or 12. It cannot be less than 2 because minimum value possible on the dice is going to be 1. When I add 1 and 1, it is 2, and maximum value that is possible on dice is 6. Therefore it cannot be more than 12 because I am rolling 2 dice. Got it? And then you can find out what is the probability that Z can take the value 2. So it is nothing but, how many cases will this 2 will come? Only one case, whenever the dice are showing 1 1. Therefore it is 1 by 36, right? In case if you want to see what happens for Z equal to, let's say, 3, then what are the favorable cases for this? All the favorable cases are nothing but 1 comma 2 and 2 comma 1. Only 2 favorable cases, and each case is having a probability 1 by 36. Therefore for this one the probability is 2 by 36. What about the probability that Z equal to 4? So what are the cases we have? So all possible cases are 1 3, 2 2 and 3 1. Therefore it is going to be 3 by 36. So on. What is the probability that you are going to get 12? So what are the events that we have here? 6 comma 6. Only this is the favorable event, right? So it is going to be 1 by 36. So again we can apply, or we can give numbers, probabilities to each of the possibility. This is called as probability distribution. Now we have seen the examples on random variables. In general, random variables can be classified like this. They can be majorly of 2 types. One is discrete random variable and other is continuous random variable. So what is discrete random variable is, all these examples are actually discrete random variables, which means the value that a random variable will give us will be a point, will be discontinuous point like this, 1 2 3 4 like this. There will be some finite set or countable set. Countable set means something like natural numbers, and from which your random variable can take the values. And what about the continuous cases? So sometimes random variable need not be giving you a single value, it might give you a range. For example, if you assume that, let's say, x is a random variable which denotes lifetime of a car. If you are talking about that problem, then lifetime of a car may not be exactly 2 years, it can be anywhere in the range of 2 to 4 years. Then we are going to represent lifetime of the car to be 2 to 4 like this, right? So in this case it is not a discrete event, it is a continuous event, because we are talking about anywhere between 2 to 4 and there will be infinite number of points possible between this, right? So random variables can be divided into 2 types, discrete random variables and continuous random variables. And even after that we can again divide discrete into many types and continuous into many types. Okay, we shall discuss about all these types, and then once we discuss it, this topic will be over. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.